Now let us quickly go to magnetism 13. In 13 we will be discussing this case. But I suggest before you watch this video, you must watch magnetism 12 thoroughly. There I had derived these two situations. Two short bar magnets, north pole facing south pole, and the center of this one and the center of this one were at a distance r. The magnetic moment of this one is from south to north, that is shown here as m1. This is magnet 1, this is magnet 2. The magnetic moment of this one was pointing from south to north, that is shown from here, m2. And at this point O1, the point O1 is on the axial line of this magnet. So here the magnetic field due to this one is B2 to this side along the axis, and at the point O2 here, that is from here at a distance r, here the field due to this magnet was B1 to this side and it was attracting. And this I had explained in lesson 12. You must go through lesson 12 before you watch this. And here, this magnet is just reversed. Means the north comes here, the south comes here. This remains as same. This magnet its orientation is just changed. North comes here, south comes here. So in this case also, due to this magnet, its magnetic moment was m1, which I explained here. Its magnetic moment will be m2 from south to north. From south to north m1. This will be from south to north, to this side, right? And here the magnetic field due to this one was B2 to this side, and here at a distance r the magnetic field due to this was B1 to this side. This was a case of repulsion, this was a case of attraction, and whether it is this case or this case, the force was I had derived F was equal to mu naught over 4 pi 6 m1 m2 over r to the power 4. Means what you have to remember is force is proportional to 1 by r to the power 4. And neither this magnet was experiencing a torque nor this was experiencing a torque. Neither this was experiencing a torque, this was experiencing a torque in both situations. So torque in both the cases was at 0, tau 1, tau 2 is equal to 0. And the energy of this one in the magnetic field of this one, and the energy of this one in the magnetic field of this one. Similarly, the energy of this one in the magnetic field of this magnet, energy of this magnet in the magnetic field of this magnet, both the energies were equal, and it had come out to be minus mu naught over 4 pi 2 m1 over to r cube. So what you have to remember is U is proportional to 1 by r cube. This is what we had done in lesson 12. Now go to 13. Now let us go to 13. Now the orientation of the two short bar magnets is now changed, right? What do you mean by that? Now this magnet, the center of this and the center of this, they are not in a straight line along the axis. They are like this. Now this is one situation, and this is the other situation. This is one situation, and this is the other situation. Means here this is the short bar magnet south north, so its magnetic moment m1 is pointing to this side from south to north. Now this is another, its magnetic moment from south to north m2 to this side. Distance between their centers is from O1 to O2 is r. In the previous case, the distance was also r, but the orientation was not like this. The orientation was like this. Now Now, at this point, at a distance r, the field due to this is B1 because this point O2 is on the equatorial line of this bar magnet. Equatorial line of this bar magnet. If you look at like this. So, and we know in equatorial line, the magnetic field was directed from north to south. This point is on the equatorial line of this this magnet. So, due to this magnet, first magnet at point O2 at a distance r, the magnetic field is B1 pointing to this side. Similarly, the point O1, which is at a distance r from this magnet, the point O1 is on the equatorial line of this magnet. Now, point O1 is on the equatorial line of this magnet at a distance r. So, due to this magnet at point O1, the magnetic field will be directed from north to south. That is shown here, from north to south, B2. So, and now in this case, this magnet is reversed like this, So, by reversing, what happens? Look, for this one, the distance remains same between O1 and O2. For this magnet, the first one, this is south, this is north, so its magnetic moment is pointing to this side from south to north. Now this magnet, south, north, so its magnetic moment is pointing to this side, M2. Now this point O1 is on the equatorial line of this magnet and the point O2 is on the equatorial line of this magnet. Now, and in an equatorial line, we know the magnetic field is directed from north to south. So let us find out the magnetic field of this short magnet at the point O2. Point O2 is on the equatorial line of this magnet. Point O2 is on the equatorial line of this magnet. So at point O2, due to this magnet, the magnetic field will be B1. So, directed from north to south. Similarly, the point O1 is on the equatorial line of this magnet, So, due to this, if the magnetic field is B2, that will be directed from north to south. So, that is what I am shown here. B2, north to south. And here it will be a repulsor, here it will be an attraction, as I discussed in Magnetism 12. Here also, the tau 2, torque experienced by the second magnet, this magnet, will be magnetic moment of the second one, cross product of the magnetic field of the first one. This is the cross product. So there will be a sine theta term. Here theta is equal to 180 degree. So sine 180 is 0. So the torque is equal to 0. You just look at M2. Look at M2 is this side. And your B1 is to this side. M2 is to this side. B1 is to this side. So what is the angle between them? 180. So if you put 180, sine 180 is 0. So the torque is 0. Similarly, the torque experienced by the first magnet having magnetic moment M1 when kept in the magnetic field B2 of the second magnet. Now look at the direction of M1. M1 is to this side, B2 is to this side. So angle between them is 180 degree. So here, since there is a cross product, there will be a sine term. Sine 180 is 0, so the torque is 0. So whether it is this case or this case, neither this magnet will experience a torque due to this magnet, nor this magnet will experience a torque due to this magnet. Similarly, in this orientation, neither this will experience a torque, neither this will experience a torque. Both the torques are 0. Now, energy. U1, energy of the first one, U2 is the energy of the second one. Energy of the first one will be, using the energy expression, U was equal to minus m dot B. Now, magnetic moment of the first one, dot product, magnetic field of the second one at the position of first one. Now look, M1 is pointing to this side and B2 is pointing to this side. So angle between them is 180 degree. So energy of this one is minus M1 dot B2. This is a dot product. There will be a cos theta term. Theta is 180. Similarly, energy of the second one, that is the second magnet, either this position or this position, will be magnetic moment of the second one dot product magnetic field of the first one. So whether it is this case or this case, this comes out to be mu naught over 4 pi m1 m2 over r cube, right? So here also you have to remember both the energies are equal and the energy is proportional to 1 by r cube. Now then, using this expression, force is the negative derivative of the energy. This is in your kinematics, work energy power. We derive, just differentiate this with respect to r, we get both the forces are equal, that is mu naught over 4 pi 3 m1 m2 over r cube. Means here also the force is proportional to 1 by r to the power 4. These two things you have to remember. Then we are left only with one more case that I will discuss in the next video. This is a case of repulsion. Distance between the centers is r, but the orientation is like this. The orientation is not like this. Here also the force was same. Here also the force, here same situation. Lesson 12, force is proportional to 1 by r to the power 4. Here also force is proportional to 1 by r to the power 4, but they are not. But the force here and the force in lesson 12, they are not equal. That you have to remember. In lesson 12, when the orientation was like this, the force was mu naught over 4 pi 6 m1 m2 by r to the power 4. Here the force is mu naught over 4 pi 3 m1 m2 over r to the power 4. And in lesson 12, your energy was minus mu naught over 4 pi 2 m1 m2 over r cube. Here the energy is mu naught over 4 pi m1 m2 over r cube, but it is positive. So that is all about